You know, for as long as we've had civilization, we've had this really complicated relationship with water. On one hand, it's absolutely essential, right? It's the lifeblood of everything we do. But on the other, it can be one of the most destructive forces in nature. We've literally spent millennia trying to tame it, and the story of how we did that, well, it's a story of some truly incredible engineering. And the scale of this effort is just mind-boggling. I mean, look at this. Across the entire globe, we've built almost 50,000 large dams. We have completely reshaped rivers and entire landscapes just to get water where we need it. It's got to be one of the biggest ways we've ever altered the face of the planet.
So the big question is, how did we get here? How did we go from just, diverting a small stream to building these concrete giants? It's been an incredible journey of innovation for sure, but also a journey of some catastrophic failures. The lessons were learned the hard way, written in stone and mud over thousands of years. Our story kicks off about 5,000 years ago. In what's now modern-day Jordan, the very first known dam was built, the Jawa Dam. Pretty amazing. But just a few centuries later, the Egyptians tried to build something much, much bigger, the Sad el-Kafara. And let's just say, it ended in total disaster. It wasn't really until the Roman Empire that building dams started to look more like a science.
And when you put these two early projects side by side, the difference is just night and day. The Jawa Dam, okay, it was small, but it was brilliantly designed. The builders actually understood that they needed to reinforce the wall against the push of the water, an idea so ahead of its time it was basically forgotten for centuries. The Sad el-Kafara, on the other hand, was this massive wall of stone with one single fatal flaw. The first time a big storm hit, the reservoir filled up, the water had nowhere to go, and the whole thing just, poof, washed away.
So it was the Romans who really started to figure all this out and write down the rules. Learning from the past, they became absolute masters of dam building. And they didn't just build one type of dam, they innovated, coming up with different structures for different landscapes. They truly mastered hydraulic engineering. Okay, so their most fundamental design was the gravity dam. And the concept here is pretty simple, really. At its core, it's just a massive, heavy wall.
The way a gravity dam works is just by being so ridiculously heavy that the force of gravity holding it down is stronger than the force of the water pushing against it. It's a simple, powerful idea, just brute force and sheer mass winning the fight against water pressure.
But what if you're building in a really narrow, steep canyon? A massive gravity dam might not work there. Well, for that, the Romans developed something much more elegant, the arch dam.
This is where things get really clever. By curving the dam into the flow of the water, all that immense pressure gets redirected outwards, pushing into the solid rock of the canyon walls. This means you can build a much thinner, more efficient structure. It's genius.
Okay, so let's fast forward a couple of thousand years. These ancient principles were scaled up, way up, to create true megastructures. And you can't talk about dams without talking about the iconic Hoover Dam, a masterpiece built back in the 1930s. And just to give you an idea of the incredible scale we're talking about now, the Hoover Dam stands 726 feet tall. That's more than double the height of the Statue of Liberty. Just massive. And these days, dams aren't just walls holding back water. They're these complex, multi-purpose machines. They generate clean electricity, they give us a steady supply of water for our cities and farms, they stop catastrophic floods, and they even create huge lakes for us to go play on. But that brings us right back to that ancient failure, doesn't it? When you've got a reservoir holding back literally trillions of gallons of water, what's the one safety feature that stops a modern giant from suffering the same exact fate as that Egyptian dam from 4,600 years ago?
While the answer comes down to the single most important lesson learned from the Sad el-Kafara's collapse, the invention of the spillway.
So what is a spillway? It's basically the dam's ultimate safety valve. When the water level in the reservoir gets too high, like during a huge flood, the spillway gives all that excess water a safe, controlled path to get downstream. It's what prevents the water from just pouring over the top and destroying everything.
And engineers have come up with all sorts of clever designs. The OG is a really common one, that smooth S shape you see on top of many concrete dams. For earth dams, you might have a chute spillway, which is kind of like a giant concrete slide for water. And then there's the shaft spillway. People call it a glory hole that acts like a giant bathtub drain, just swallowing water right from the surface. For most of the 20th century, the whole game was just build bigger, build stronger. But in the last few decades, we've started to really understand the huge environmental impact these structures have, and the entire way we think about dams, it's starting to shift.
In fact, this might surprise you, but since 1990, more than 900 dams in the United States alone have actually been removed. Yep, taken down. It's a massive effort to restore river ecosystems, let fish migrate again, and get rid of older dams that might not be safe anymore.
And this image, it captures this new chapter perfectly. You're looking at a dam not being built, but being carefully taken apart. It represents this huge shift towards a more balanced approach, one that really weighs the benefits of a dam against its ecological costs.
So we've gone from the first little earthen dam at Jawa to these modern giants of concrete and steel, and now to an era of actually removing them. It leaves us with a really fascinating question. As our world keeps changing, what's the next chapter going to look like in our long, complicated, and powerful relationship with the world's rivers?